First, we find how many meshes we have, then we assign those meshes currents, then we find equations or mesh equations using Kirchhoff's voltage law. It means the sum of the voltage in a loop equal to 0. Once we find the equations, we solve them to find the mesh currents. Now there is a special case when you have current sources in the circuit. Now current sources, this is a voltage source, so this is a current source. We're talking about this, and we're talking about this guy. So when we have a current source in a circuit, or more than one current source, what do we do? A special case, because the reason that the voltage source tells you the voltage, so it's okay. For example, in this loop, it's really easy to find the equation. The voltage cross here plus the voltage here, which is 4 times I1 here, and the voltage here is 6 times I1 minus I2, or I2 minus I1. Okay, this is the voltage here, this is the voltage here, this is the voltage here. But when you have a current source, you don't know the voltage across the current. So what is the voltage across the current? I want the sum of the voltage equal to 0, but I don't know the voltage here, so I cannot have the equation. So when I have a current source, I cannot make this equation. I cannot, because I don't know the voltage across the current source. For example, if I start in the second loop here, I can do plus minus my polarity. Okay, so I'm gonna do the voltage here is minus 6 times the current I2 minus I1, then minus 3 I2, then what is the voltage here? It's not 5. This is the current. What is the volt? I'm gonna need to add the voltage here. What is it? I don't know. I can't make the equation. Khalas. Becomes difficult. This is why if we have a current source, we can't make the equation. The sum of the voltage is equal to 0, because we don't know the voltage across the current source. So what we do, two cases. If the current source is in one mesh, like here. This is a mesh. This is not between two meshes, it's in one mesh. In this case, this mesh is solved. This mesh is solved. It means the current of this mesh is easy to find. If it's between two meshes like this is in this mesh and this mesh. So if the current source is in between two meshes, what we do, we create a super mesh. Why is the super mesh? We go around. We don't go through the branch. We go around like this. And we make the equation here, the sum of the voltage equal to 0. Now, because we have two meshes, we need a second equation. The second equation is called the current source equation, which is this current equals to what? Equals to the current going this way minus the current going this way, this 6 ampere. So it's I2 minus I1. That gives me the second equation. Now we will see an example or examples of this. Look at this one. In this here we have a current source. Khalas, once you have a current source, think of different ways. You're not gonna do sum of the voltage equal to 0 right away, no. Because you don't know the voltage across this guy. So if you have a current source, you ask yourself a question. Is the current source between two meshes or in one mesh? Can anyone answer this? Is the current source here between two meshes or in one mesh? Any answers? Is the current source in one mesh or between two meshes? First, how many meshes do we have here?
Between two meshes.
Between two meshes, because this is one window and this is another window. And this guy is in between. So once current source is between two meshes, what do? We go back to here and say, we create a super mesh by excluding the current source branch. So the current source branch is gonna be removed, okay? And I'm gonna have a super mesh. Okay, so what I'm gonna do, the current branch, whatever in that current source branch, even if I have resistor here, even if I have inductor here, even if I have battery here, okay, they're all gonna be gone. So this is gonna be removed. But before we remove it, we're going to just use these first steps. We're going to use the first steps here. Two meshes, assign the first mesh a mesh current, the second mesh the mesh current. But this is before starting the analysis. Okay, now let's look at this 4 ampere here in this branch going this way. So this 4 ampere will equal to the current I1 minus the current I2. This 4 ampere going this way is the current I1 with me minus the current I2, which is opposing me. So if I1 is 6, I2 will be 2. The total will be 4 going down, this guy here. 4 will be 6 minus 2. So the 4 ampere, the branch current, which is the source current, is going to be equal to the combination of the two mesh currents. The one in my direction is positive, the one in opposing my direction is negative. So this is one thing. This is one equation. Then I'm going to remove this and use the super mesh. When I use the super mesh, this is the mesh 1, this is the mesh 2. I combine both together, they make a super mesh. Okay. So in a super mesh, I'm going to do what? I'm going to actually add sum of the voltages equal to 0. So I'm going to do 20 minus the voltage here, minus the voltage here, minus the voltage here, plus 12 complete equal to 0. Why is the voltage here is 6I1? Why is the voltage here is 4I1? Why is the voltage here 2I2? Because the current here is I2. This is my second mesh now. I combine the two meshes together. So I would have two equations. So this is the second equation. And this is the first equation when I said the 4 will equal to I1 minus I2. Now these two equations, which is this equation and this equation, you solve them together, you're going to get a solution. Once you have the solution, you finish it mesh analysis. Okay, you can find voltages or currents or whatever you want. We're going to do an exercise here. Use the super mesh or use mesh analysis here, okay, to find the current in each element. Okay, so now this question is quite long, so it might take it some time to do it, but what we have left is just exercises. Okay, so let's do question 4, exercise 4, and if we can do 5 and 6, then would be great. The rest of the exercises can be good work for you, and the answers are at the last slide, the key answers. How many meshes do we have? Can anyone answer this question? How many meshes do we have? How many loops do we have? How many?
3.
3. That's true. I have this window and this window and this small window. 3 mesh currents. Okay. So what I'm going to do, the first step, I'm going to give them current per every mesh. This is, I'm going to say this is 1. This is 2. And let me just say this is 3. Now, in the 4 ohm resistance, how many mesh currents are going here? How many mesh currents are going in the 4 ohm resistance?
Only one?
That's only one. It's I1 only. Look, I1 goes here. I'm going to do this again with different colors. Shows you. So this is I1. Then this is I2. then this is I3. So I3 goes here, here, and here, and here, and here, and here. This is I3. I1 goes here, 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 goes here, and here. Then I2 goes this way, goes this way, goes here, and goes here. So in this 4 ohm, only I1. What about the 6 ohm? How many mesh currents are going through 6 ohm? How many mesh currents are going through the 6 ohm resistance?
2.
2. The red is in this direction, the green is in this direction. So it's the mesh current I1 and it's the mesh current I3. Both of them together, they make together, when we add them or combine them, we get the current in the 6 ohm resistance. Is this okay that you can see that actually how many currents are going in the mesh in every element in the network? For example, in 1 ohm is only I2. In the 8 ohm, it's I2 and I3. In the source 8 ampere source, only I3. In the 20 volt source, it's only I1. In the 3 ampere source, there's 2, I1 and I2. Is this okay? This is important to know the current in the element, and I don't think it's difficult. If the element is between 2 windows, then there are 2 currents. If the element is in 1 window, then it's 1 current. Any questions about this? I don't know. It seems that it is really difficult. When there is no response, it means no difficult. This is a window, and this is another window. Whoever here is only in window 1. Whoever here is only in window 1. But whoever here is between window 1 and window 2. Right? This is between the 2 windows. But this is not between 2 windows. This is only in 1 window. Sometimes I think I'm explaining something, it's really simple, and you guys think it's really complicated. So maybe instead of thinking if this element, you're thinking like that. You're making questions marks like this. And what do you mean by window? Do you mean window is find, or you mean window is current? Or you mean, no, it's just this part of the circuit that makes a closed loop. Okay. Now, how many current sources do we have in the circuit? How many current sources do we have in the circuit?
We have 2.
2 current sources, okay. So the 3 ohm, the 3 ampere current source, is it between 2 windows or in 1 window? Is it in 1 mesh or 2 meshes? This is 3.
In 2 meshes.
That is between 2 meshes. So mesh 2 and 3. Sorry, 1 and 2. Why is it? It's 1 and mesh 2. They have current source in between, so I'm gonna use the super mesh here for these 2. I'm gonna use the super mesh for 1 and 2 because they have current source between them. What about mesh 3? What about this current? Is it in 1 mesh or 2 meshes?
Just only 1.
So mesh 3 has current source and it's only in it, and that means this mesh is solved. This current 8 ampere is actually the current, the mesh current I3. So I3 right away equals to 8 ampere. The third mesh is solved right away because this is the direction of the mesh current. And it is the same direction as the source and it's in the same branch. So mesh current here will equal to the 8 here because this is the current here. The current here is 8 ampere. And this is the information that this source tells me. Tells me the current here is 8, which is the I3. So we finish at I3. Now we're going to do the mesh current for these two. So we're going to create two equations. One is the current source equation. The second one is the super mesh equation. So what is the current source? Look at this is 3. 3 ampere going up. Okay, 3 going up. What is going in the same direction? It is I2. What is opposite direction? It's I1. So it is I2 minus I1. This is the first equation here. From this equation, I can say I2 equals to I1 plus 3. So the 3 ampere in the branch is the combination of these two currents. The 3 going up, so it is I2 is in the same direction, it's positive. I1 is in the opposite direction, so it's negative. Now the super mesh, how do we do the super mesh? When we do the super mesh, we're gonna eliminate, exclude this branch. So this branch is not there. And we're gonna go in the big mesh like this. So we will go in this mesh. Which is a super mesh because it's a combination of two meshes. So the polarity here of this, according to the mesh one, positive here, negative here, positive here, negative here. Now this is in the mesh two, so this is the polarity according to the second current, positive here, negative here, here, negative here. Now in the big mesh, I have the voltage source, 1 resistor, 2 resistors, 3 resistors, 4 resistors. So I'm going to have 5 voltages. I'm going to start from this point. This is gain 20. Then I'm going to lose the voltage here, which is minus 4. What is the current going here? Is I1 only. Then minus, because I'm going from positive to negative, minus 6. And the currents going in this one, two currents, I1 and I3. This is between I1 and I3. So it's I1 minus I3. Then minus 8. And the currents going in this is I2 minus I3. I2, sorry. Then minus 1. And the current is I2 equal to 0. Those are the voltages. See, the 6 is between 1 and 3. The 8 is between 2 and 3. This 1 ohm is only in 1. This 4 ohm is only, in 2. This is 4 ohm is only in 1. So how many currents are going in here? Just I1. Here, it's I1 and I3, and their opposite direction. I3 is in this way, I1 is in this way. So because I'm doing the mesh 1 here, it's I1 minus the other one. Here I'm in mesh 2, so it's I2 minus I3. This is a combination of mesh 1 and mesh 2. So I go through mesh 1 until I finish it, then I start mesh 2 until I go back to the same point. I can simplify this. 20, I have minus 4I1 and minus 6I1, so it's minus 10I1. For I2, I have minus 8I2 and minus 1I2, so it's minus 9I2. Then here plus 6I3 plus 8I3, so plus 14I3 equal to 0. Now I know what is I3. It's 8. I can plug it here. So this is plus 6 and this is plus 8. Minus 8 times negative I3. So from here 20 minus 10 I1 minus 9 I2 plus 14, and this is 8 times 8 equal to 0. So I can simplify. Why did I write 18? Equal to 0. So 8 times 14, 8 times 10 is 80. So it's 112, 132. So this equals 132 minus 10 I1 minus 9 I2 equal to 0. This is the second equation. And this is the first equation. And this is the third mesh already solved. This is the third equation. I can substitute 1 and 2 to solve. So here I2 equals to that. So 132 minus 10 I1 minus 9. Then here I2 is I1 plus 3 equals to 0. So from here, this is 19 minus 19 I1. And here is minus 27. And this is 132 equals to 0. So this is 105 minus 19 I1 equals to 0. So here I1 equals to 105. Move this to the other side, then divide by 19. So this is gonna be 5 point something. 5.55, I think, something like that, ampere. Then I can find I2 from this equation. Just add a 3, so it's 8.55 or 56 ampere. I found the 3 currents. Just look at the answer at the last page. Oh, 5.53, okay, not 55. Okay. So this is 5.3. And this is 5.3. Ouch. So this is the answer for the mesh. Now we're going to use the mesh currents to find the current everywhere. So because this is the first mesh, so the current here is 5.53. It's going to be the same here, 5.53. The current here is 8. It's going to be the same here as 8, right? The current going this way is going to be 8 0.53. The current here is a 3. Now the current here is going to be this way. See, there is 5.53 going this way, 5.53. And there is 8 going this way. The 8 is more. 8 is more than 5.53. So when I combine them, it will be 8 minus 5.53 in this direction. So it will be the current here will be 8 minus 5.53, which is 2.47 going that way. So this is, there's 2.47 going this way, and here it will be 0.53 going this way, and this is a 3. Those are the currents. The mesh here is 8.53. The mesh here is 5.53. The mesh here is 8 ampere. In the 8 ohm, it's 8.53 minus 8, so it's 0.53. And this 3 is 8.53 minus 5.53, the bigger minus the smaller, and it's in this direction. In here, it is 8 minus 5.53, and here is 8, and here is 5.53, so it's 2.47, and it's in the direction of the bigger current. Is this question okay? A lot of work, a lot of work, a lot of things, lots of numbers, but at the end, the mesh current is the current in the loop. You can use it to find the branch current. If the branch is between two meshes, combine the two currents. If the branch is in one mesh, then the branch current equals to the mesh current. Like here, this branch is in one mesh, so the branch here equals to the mesh current. Here, the same. But this branch is between two meshes. This side is 8.53. This side is 5.53. So what is the total? The bigger minus the smaller, and it's the direction of the bigger. Can I delete this and just put it like this? I'm gonna make it a bit bigger. The current here is 5.53. The current here is 8.53. The current here is 8. Okay, so the current here is 8. Here it is 8. Here it is 8 because there is one here, there's one mesh. Same here, 8.53 and 8.53. Here, 5.53, 5.53. Now this is between, this one here is between this and this, between the 8 and this one. Now the 8 is going this way. The 5.53 is going this way. Which one is bigger? The 8. So the 8 is going to be, the 8 flow is more than the 5 flow. So what is going to win? This guy is going to win. This. Oops. Okay. So the total in this branch is going to be this way, and it's going to be the difference. So it's 8 minus 5.53, which is 2.47. And it's in this direction because the 8 is more than the 5. Here we have 8 going this way, 8.53, and we have 5.53 going this way. So who is going to win? The total is going to be this 3 ampere, the difference between them in the direction of the bigger flow. Here you have 8 in this direction and you have 8.53 in this direction. So the total is going to be 0.53 in this direction. Those are the branch currents. Those are the mesh currents. Sometimes the mesh current equals to the branch current. Sometimes it's not equal. Is this okay? Is this fine? Yes or no? Any questions? Any questions? See, when there are no questions, it's really scary. It's really scary. It means the class have no clue what is happening. This is to me when there's no questions. And when you ask question and no answer, that's even worse. Means the class is even scared to give you an answer. You know, when you have no idea about the topic, you're scared to give an answer. I don't think it's too complicated, but what can I do? Hopefully this is okay. And if it's not okay, please let me know. Send me an email sometime and say it's too complicated.
Sorry for interrupting.
Yes.
But can we make after Eid like class in campus maybe? If this is possible, or it will not be? Or it's gonna be hard or no?
No, you know, if we had classes on campus, lots of you will find it really easy, the course. Online is not efficient, it's not good, but now this is a government rule. You can't have classes on campus. You can't. The only thing that once you're here during the your lab sessions, because you're here, I can maybe have a small class for each lab group to review a few things. But what I can do, I can have tutorials, and I said several times, we can have extra tutorial classes. No one asked any questions, so I was like, why would I bother? And you know, if people don't ask
Because
questions.
like in campus, we can like understand more and it's become more easier for us to understand.
That is totally true, but the question, would they let us? I don't think so.
You can ask.
Oh,
Like
I
you
did.
can ask if they say no, it's okay. If they
I
say
already asked, and they're so scared to say yes.
because like online and ET, it's really hard, you know.
I understand.
Not
I understand. Can you ask? Maybe you can try. Me, I failed. I asked. I did not want the class to be online. I did not want it to be online, but they said no.
So there is not like any chance for us to be in campus.
I'll try again. I'll let you know. I'll try just to use the lab excuse. So I'll use the schedule next to the lab time. Anyhow,
Yes, it will be great because like online is really hard. It's not easy. Like for the circuits and stuff like that.
you try your best, and this is what we can do. But
Yes, okay.
we will, as I said, if you want a tutorial, an extra class, we can have an extra class.
We can have an extra class after 8.
Yes.
It will be great. Yes.
Okay, so let's take the attendance and let you go so you enjoy your Eid vacation. The exercises from 5 to 7, 3 exercises left in this. You can try them on your own. If you have issues, let me know. And I will see you after Eid.
Yes. Thank you, sir. Have a nice day.